In today's video, we are going to learn where the numbers that we know they lie, or where do our numbers that we know they live. What is the address of the numbers that we know? First, let's see what are the numbers that we know. We know whole numbers. Whole numbers are 0, 1, 2, 3 and so on. So 10,000 is a whole number. 1 lakh is a whole number, 1 crore is a whole number, 1 million, 1 billion, all these are whole numbers. It starts with 0, 0, 1, 2, 3, 4 and on. Integers are all the minus, we can say minus 3, minus 4, minus 1, 0, 1, 2, dot, dot, dot. So all these are integers. Now out of these integers, the plus ones, the positive ones are called positive integers. So positive integers are 1, 2, 3, dot, dot, dot. So lots of positive integers. And the negative integers are those integers with a minus sign. So minus 1, minus 2, minus 3, dot, dot, dot. So if I say positive integers and negative integers together make integers, am I right or am I wrong? I'm wrong, since we are going to miss 0. So positive integers, negative integers along with 0 make these integers, the collection of integers. Now which ones are natural numbers? Natural numbers are 1, 2, 3, 4, 5, dot, dot, dot. So, is there any difference between positive integers and natural numbers? No, they are same. Now, what are rational numbers? Rational numbers are any number of the form p by q, okay, where q is not equal to 0. Because it is in the denominator, it cannot be 0, and p can be anything. Negative numbers, negative integers, positive integers, 0, p can be anything, and q can be positive or negative integers, but it cannot be 0. Like, these are examples. There are lots of rational numbers. These are just examples. Half, that is in the form p by q, 1 by 2. This is minus 1 by 2 in the same form, p by q. This is minus 7 by 2 in this form. Now what about 3? 3 is also in this form because 3 is actually 3 by 1. So it is a rational number. What about 0? 0 is also a rational number because 0 is actually 0 by 1. What about minus 4? It is also a rational number because it is minus 4 by 1 written in this form, like this. Now irrational numbers. Irrational numbers are, there are lots of irrational numbers. For example, we have just written root 2, root 3, root 5, root 6, root 7, minus root over 11, minus root over 10, dot, 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 which means there are lots of irrational numbers and all of them are not written here. Just a few are written over here. Now the most important thing is, what are real numbers? Real numbers are actually all the rational numbers plus the irrational numbers. All the numbers that we know till class 10 is, or they are actually real numbers. In class 11 we learn complex numbers, imaginary numbers. Those are separate. Up to class 10 our idea is limited up to real numbers. So let's see how are these positioned, okay? Where do these numbers lie? How do they lie with respect to each other, okay? So let's move on. Now let us represent the space in which the numbers lie by circles. So suppose I draw a circle over here, okay? Suppose this is the circle where the positive integers lie. So this is the address of the positive integers. This is the house where they lie, the positive integers. Now suppose the negative integers lie or they live in this house. -2, -1, -2, -3. All the negative integers, they live in this house. We are representing their living spaces by circles. These are actually called sets. Okay. So this is the set of positive integers. This is the set of negative integers. Now where will our 0 lie? 0 is neither in the positive ones nor in the negative ones. So let me put 0 over here. Now the positive integers 0 and the negative integers, they together lie in a space which is called the set of integers. It can be oval, it can be a circle. This is the set of integers. So positive integers, negative integers along with 0, they lie in a space which is called the set of integers. Now remember, then we studied the rational numbers. So rational numbers, all these are rational numbers. Along with these, half, minus half, anything of this form, suppose -11/2, -27/55, all these they live in another space or circle that is denoted by Q and called the set of rational numbers. So if I say this big circle is the set of rational numbers, then everything lying within this, okay, within this big circle, all of them are rational numbers. So it is very clear from the picture that all the integers are rational numbers, which means all the positive integers are rational numbers, 0 is a rational number, negative integers are also rational numbers. Everything lying within this big circle is a rational number. Everything within this. Now if somebody asks me, is a decimal number a rational number? If I say 0.01, what is this actually? This is actually 1/100. So this can be actually written in the form P/Q. So it is a rational number. Okay. So what about 0.3 recurring? This is a recurring decimal. What about a recurring decimal? It is also a rational number because 0.3 actually can be represented in this form 3/9, which is 1/3, which is of the form P/Q, hence a rational number. So can you think of any number? If you have any queries, you can write it in the comments. So all the decimals, the recurring decimals, the fractions, the positive integers, 0, negative integers, all of them, they lie in this big circle which is called the set of rational numbers. Now irrational numbers, where do those lie? Those are absolutely separate set. Here the irrational numbers lie. Okay, suppose √2, √5, √11, √10, -√13. These are all irrational numbers. These are non-terminating. If I want to break it up into, if I want to find out √2, it will be 1.414 ... something. Those numbers will be non-recurring, non-terminating. So these are examples of irrational numbers. Are these the only irrational numbers? Absolutely not. There are lots of irrational numbers, but for now we are going to learn only these. There are lots of irrational numbers. So this is the set of rational numbers. This is the set of irrational numbers. The way I have drawn it, it seems as if the irrational numbers are smaller in number. But no way. Both are infinite. There are lots and lots of infinite number of rational numbers and infinite number of irrational numbers. Now what about the real numbers? This big house. This big house which contains two big rooms, the rational numbers and the irrational numbers. This big house is called the real numbers. The set of real numbers. Okay. So if you can picturize this, you will never forget which number is what. Real numbers are all the numbers that we know up to class 10. Real numbers, the big house of real numbers, has two big rooms. The room of rational numbers and the room of irrational numbers. In the room of rational numbers, there are even smaller rooms. There is a smaller room which is the room of integers. In the room of integers, there are two other rooms. In one of those lie the positive integers. In another room lie the negative integers, and 0 lies alone. So all these three together make the room of integers. Okay. Hopefully this idea is clear. Where do your numbers lie? Do not forget this ever. Thank you.